For this question, we could just put this into Desmos. I will show you another way to do it by hand, but Desmos is pretty tempting here because we don't have to worry about doing the actual math. So that's cool. So I'm going to put this into Desmos. Now remember when you, oops, let me make this X. When you put an equation into Desmos like this, where you have X's on both sides and no Y, you're not going to actually get the graph of the function, but you will still get the solution. So where this, I won't call it curve, where these lines intersect the x-axis are actually going to be your solutions to this system. And so we can see negative 5 and 5. And since t is got to be positive, we know the answer has got to be 5. And so you can put that in, you're good to go. Now, what if we wanted to solve this by hand? What if we had to solve it by hand because they did something where you wouldn't be able to plug it into Desmos, let's say? What could we do? So the goal here is to get a common denominator for these terms so that we can combine them or maybe cross multiply or something. And in fact, what I'm going to do, it might be tempting to find a common denominator for all of these terms. And you could do it. It's going to get a little messy just because these are not going to have a common denominator that's anything but just their product. So the common denominator of these guys would be t plus 1 times t plus 3. And so it'll work, but it's a little messy. What I'm going to do is I'm going to actually combine these terms. So let's get these to have a common denominator, and then we'll move on to the next step. So on the left side, we're going to leave it alone, 3 over t plus 1. But here, what's the common denominator of 4 and t plus 3? So it would just be the product, in this case, 4 times t plus 3, which means this term right here, 2 over t plus 3, I'm going to need to multiply it by 4 over 4 so that I've got that common denominator. And remember, I can do this. I can multiply by 4 over 4 because I'm just multiplying by 1. And by the multiplicative identity, anything times 1 is itself. So we're not breaking anything. And we do the same thing with 1 over 4, except this time I'm going to multiply this guy by t plus 3 over t plus 3 because that's what he needs to have that common denominator. So let's see what we get. Once I multiply these numerators, 2 times 4 and 1 times t plus 3, I'm going to have the same denominator, and so I'm just going to add the numerators. So I'm going to get 8 plus t plus 3. And let me actually just make that 11 plus t at this point, right? 4 times 2 is 8, t plus 3, cool. All over 4 times t plus 3. All right, so now the reason why I wanted to do it this way is I can just cross multiply, and I don't actually have to worry about getting a common denominator with this guy because I can just multiply across. So let's cross multiply 12 times t plus 3 equals, so I'm going to write this out this way, t plus 1, t plus 11. So I'm going to get 12t plus 36 equals, I have to FOIL this, t squared plus t plus 11t plus 12t plus 11. Oh, cool. The 12t's cancel. That makes things easy. So we'll actually bring the 11 over to the other side. We'll subtract it from both sides. So we get t squared is 25. And so when we square root both sides, we'll get t plus or minus 5, which should sound familiar. It's exactly what we saw in Desmos. And again, for the same reasons, t equals 5 is our answer.